torque experienced by an electric dipole in the uniform electric field. Now we have to consider an electric dipole of dipole moment P placed in an uniform electric field. Here, the uniform electric field is represented by parallel lines and they are equally spaced and they are in the same direction. Now, a dipole is placed here. You know what is a dipole? Two equal and opposite charges separated by a small distance. Now this dipole is placed at an angle theta with that of the electric field. So this is your direction of the electric field. So this is making an angle theta with that of the electric field. Now this is a positive charge and this is a negative charge. Now this positive charge is experiencing a force in the direction of the electric field. So this is experiencing force. The force F is equal to QE. And this negative charge is experiencing a force opposite to that of the direction of electric field. So F is equal to minus QE. Now these two forces are equal and opposite. So the net force acting on the dipole is 0. So the charge plus Q experiences a force QE in the direction of electric field. The charge minus Q experiencing a force minus QE opposite to the direction of electric field. So the net force, is equal to plus QE minus QE. So which is equal to what? 0. So the total force acting on the dipole is 0. Okay. Now these two forces are acting at different points will constitute a couple and the dipole will experience a torque. You can see here these two forces are acting at different points. Since they are acting at the different points, they will constitute a what? Couple, and this couple will produce us a torque. Okay. Now the torque will tend to rotate the dipole. The torque tends to rotate the dipole. Okay. Now we have to find out the total torque about the point O. O is the midpoint of the dipole. O is the midpoint of the dipole. Now we have to find out the total torque on the dipole about the point O. So now we can write the torque is expressed by the letter tau. Torque is represented by tau vector. Now what is tau? According to the definition of tau, you should know tau is equal to R cross F vector. Okay. Distance into force. Distance into what? Force. Now we are going to write the total torque acting on the dipole. So I am going to write it here as. Now what is the distance between charge A and O? The charge A and O is OA. Okay. And the force is what? Minus QE. Similarly for charge, here it is positive charge. So positive charge and O is what? A. So that is OB. OB into QE. So we can write OA vector cross minus QE and OB vector cross plus QE. Okay. We are using the formula R cross F. Your R is for the negative charge, your R is OA. And your force is what? Minus QE. Here it is your R is OB and your force is plus QE. So now I can write it as OA vector cross minus QE vector plus OB vector cross plus QE vector. Okay. Now you know what A cross B vector is equal to modulus A vector modulus B vector into sin theta. So now I'm going to apply here. So I can write OA modulus to minus QE modulus sin theta plus OB modulus QE modulus into sin theta. You know OA vector is equal to A and OB vector is also what? A. Okay. So we can write A modulus of QE is QE. Okay. Plus sin theta plus A QE sin theta. So we can write, so this is your tau. So tau is equal to 2AQE sin theta. Okay. Now we know P vector is equal to 2AQ. Okay, that is dipole moment. So we can write tau is equal to PE sin theta. Okay. Now PE sin theta can be written in vector form as P cross E vector, because A cross B is equal to AB sin theta. So here we can write P sin theta is equal to P cross E vector. Okay. Now what is theta here? Theta is the angle between P and E, that is dipole moment and electric field. Now what is the direction of the torque? So the direction of torque is perpendicular to the plane of the paper. And is directed into it. Okay. So here it is the torque. You know the direction of P and the direction of E. But the direction of the torque, you should know the direction of the torque is what? Perpendicular to the plane of the paper. So you know this is the plane of the paper. So the direction is like this, perpendicular to the plane of the paper, and it is directed into the field. Okay. Now, when the torque is maximum, the torque is maximum okay, when theta is equal to 90 degree, that is P vector is perpendicular to E vector. Okay, dipole moment is perpendicular to that of E vector. So we can write tau is equal to PE sin 90 degree. You know sin 90 is 1. So tau is equal to PE. So the torque is maximum and theta is equal to 90 degree. Now the torque is minimum. When theta is equal to 0 degree, that is P vector is parallel to E vector. That is P vector is parallel to what? E vector. Then you can write tau is equal to PE sin 0. So what is sin 0? Sin 0 is 0. So tau will become what? 0. Tau will become 0. In this case, the dipole is aligned in parallel with that of the electric field. Here in this case, the dipole is perpendicular to that of the electric field. Okay.